Greetings, friends. My name is John Gabriel, and this is the New Calculus channel. Today, I'm going to talk about two topics. One of the topics is about comments on the internet, and the other one is a discussion which centers around a comparison between the flawed mainstream calculus and the new calculus. So let's begin. Now, a long time ago, somebody put this comment here on Reddit, which is really a trash heap in my opinion, and I didn't see it until recently. I can't address it anymore because it's archived, and I wouldn't really bother. But in any case, it's full of ad hominem and information which is mainly ignorance personified. But in any case, the first comment says his definition of average is literally something I would expect to hear from the grade school kids I work with. Well, that's really strange because an arithmetic mean, not an average, is the reason calculus works, okay? So for example, it doesn't matter whether you're dealing with vector calculus or any other kind of calculus, you are using arithmetic mean. For example, if you're calculating a surface area and you take the cross product of two vectors, which is perpendicular to those two vectors, it's called a normal. So finding the area involves taking the arithmetic mean of all those normals, right? And in any case, what these fools here carry on talking about is this lesson plan that I created. I think it's this one here. So in the lesson plan, I put a few terms here. I should have said arithmetic mean there, but it doesn't matter. The correct definition of arithmetic mean is given in my free ebook. Oops, I uploaded the French version. It doesn't matter. I'll put a link to the English version too. But here is the definition of what is an arithmetic mean. An arithmetic mean is basically that value that all the numbers of the group would have if they were made equal through redistribution, okay? So that's what it really is. And without the arithmetic mean, calculus does not work, okay? And I have an entire chapter on the arithmetic mean in my free ebook, right? So I think it's chapter 7. All right, so I'll close it up for now. I don't need it. And I had a free example here which shows you that beginning with the very first concept, as you see here, of the area defined as a product of two arithmetic means. That is what the calculus lesson is actually about, okay? So it tells you that you start off with that concept and you develop it all the way into irregular areas using the new calculus definition, which is the way the derivative is defined like this, and the way the area is defined like this, okay? Because the area is a product of two arithmetic means, right? So, and this graphic here summarizes the entire new calculus in 3 lines. That's the derivative, and this here is the fundamental theorem, which comes from the mean value theorem of calculus, all right? You can find that on my new calculus site. And so, I'll come back to the slide in a moment, but this was the lesson plan, and these fools were discussing it, which is, it's amazing to see the ignorance on this site. Okay, so I'm reading down here, and there's a problem with, here this guy assumes that I'm part of the American education system. I wasn't educated in the United States. I wasn't even born in the United States, even though I am an American through naturalization, obviously. And the problem with most education systems is that most students think the other half is below average. Actually, I'll tell you what, that's not the problem. The problem is that most teachers don't know their content. That's the problem. That's the real problem. Most professors of mathematics and teachers have no idea of how to teach the subject because they've never really understood it. And inevitably, most people are ignorant. That is a fact. So it's not as if, one can say, wow, whatever the teacher says is fact. It's not. So they carry on talking crap, a lot of crap. I mean, I just don't have too much time. So this guy here says, where I said area is the ideal surface, it says, what? A plane is a flat area. Rubbish. An area is the product of two arithmetic means. That was what the calculus lesson was getting into. Of course, I didn't want to say everything immediately in the terminology section, but if one carried on reading it, they would have found out what I meant. So he says that, and I've just explained to you that to calculate a surface area, which is planature, by the way, because what you're doing when you calculate an irregular surface area is you're converting that area into a plane by taking the arithmetic mean of the normals and multiplying it by the arithmetic mean of one of the intervals, okay, depending on which way you're going to do it, because it's three-dimensional. So these stupid people just carried on and on and on, and you know, another funny part is that this guy says, yeah, you couldn't even be bothered to find and paste an actual copyright symbol. Come on, you know, I mean, is that important? Who cares? And oh, this guy here says, what the hell is MNN in the definition of the new calculus? Well, you know, if you read my free ebook, you'd actually find out what is MNN. Okay, so let's quickly look at a comparison just for the derivative. So in the flawed calculus, the finite difference quotient, and I'll give you a link to all these applets, the finite difference quotient is never the derivative. And of course, at the point of tangency, it's entire garbage. Okay, so for it to be true, this here literally has to be 0, which means h must be 0. Not possible. However, in the new calculus, it doesn't matter where you are. The derivative will always be the correct value, okay? So you can move different M&M pairs, and you'll see that the derivative down here doesn't change, okay? And I'm going to move this back here, and you'll see that it will be -3, okay? So it doesn't matter where you are. In the new calculus, this expression here is always 0, this q of x mn, whereas in the new calculus, it's never 0, it's not allowed to be 0, and yet if it's not 0, you don't get the derivative. How's that? Isn't that crazy? So, but there is much more wrong with the mainstream calculus, because this is the ill-formed definition of limit, the ill-formed limit definition, and you see that you have an L in here, which happens to be what you're looking for. So it's circular, because in order to evaluate this part here, this right-hand part here means this first order logic expression that you see, this propositional logic that you see here at the top, okay? So so you don't know L, but you have to use it in its very own definition. So it's really a bunch of garbage, all right? And I'm not going to harp on that. I'm going to leave that alone now. And I'm going to show you also that the integral definition is flawed too, because you don't have to do all this garbage here, which is ill-formed, because it uses limits and the concept of infinity, okay? This is the definition. I've got the same example here where you use the mean value and a product of two arithmetic means. And to actually demonstrate how it works in the new calculus, I show you. This is the integral. This green part here is the integral in the new calculus, and it works for any value of k, right? So as you can see, it doesn't matter which k you choose, the value will always be the same, right? So the new calculus is well-formed concepts. So whatever you use, you will have the precise results. And this explains to you how it works. And also the new calculus has an auxiliary equation, like I showed you. So this is the graph of it here, but that's a little too advanced for most of you, because you can do a lot of things with the new calculus. But I'm going to show you very quickly that in this case here, when you look at the comparison, this q of xmn equal to 0 is the auxiliary equation, right? So you can read up on that in my free ebook. So now it doesn't matter what you do here, and as you can see, it's always, the area is always a product of two arithmetic means. Again, you know, Dennis Muller must have been smoking some kind of weird substance when he wrote that blog about me, which is full of garbage in any case. You know, the one called Logical Fallacies. All right, so now another thing that mainstream academics do not understand is that area in calculus is usually calculated by taking the difference of the boundary values. As you see here, this green area is really just equal to 2, okay, because it's simply the arithmetic mean of all the horizontal lines and all the vertical lines, which is 2 times 2. Which is 1 times 2. This is 2 and this is 1, so the area is 2. And the second example shows you again that you have this, if you want to find this whole area here, it'll be 9 minus 4, so the area will be 5. And similarly, if you integrate this function here, you will have this entire length here minus this side here, and it'll give you an area of 6.6 1/3, right? So again, the MVT does not work when you do not have a smooth function, okay? So you couldn't take, for example, if you had this or this, you couldn't take the difference of the boundaries. You'd have to, in each case, split the entire graph into smooth functions, okay? Because calculus does not work on any function that is not smooth. And what does smooth means? It means that it has exactly one tangent line at every point, not like these kinks that you see here, where you can have many tangent lines. Only one tangent line, and a tangent line never crosses a curve at the point of tangency or intersection, okay? I'll also put a link to this so you can see how this works. And then finally, I want to get back to this and show you that another site says, wasn't mathematics itself being self-destructed? And there was an answer here in which a lot of academics commented, but it's no longer here. I'll tell you why this answer is no longer here. Because somebody called Jack Hazinger, and of course you can view 11 other answers, somebody called Jack Hazinger wrote a comment which he later retracted, and he's part of the Quora administrators. He's a professor at Illinois State. So he wrote a whole critique, and he withdrew it from Quora. So that doesn't even appear there any longer. And there's a whole debate. Basically, it's a debate in which I had a conversation with Anders Kaesorg from MIT. Okay, so a lot of foolish academics here came on and placed a lot of comments which are totally garbage. Okay, so let's go to this site here, and I'll show you which one I mean that's no longer on Quora. It's this mathematics, why does John Gabriel state that the standard calculus is flawed? So if you look this up, you'll see that there are people here who do see some of the points I make. But of course, this here is no longer available on Quora. So if you search for this question, it's gone. And that's the reason, because this professor here wrote some garbage here, as you can see. It says the question title are not the place, etc., blah, blah, blah. And then he had some more to say further on. He wrote in, here he goes again. He says your level of whatever. So he's constantly attacking me. And then finally he writes a critique which is entire garbage. But the conversation continues between Anders Kaesorg and me, and you'll see that, so here is his main critique, which is no longer on Quora. You can read it here. John objects to the fact that we can construct real numbers. Of course I object. Cantor's own delusional ideas about objective cardinality prove that there are no real numbers, because if real numbers did exist, you'd be able to list them systematically. There's no way to list them systematically because they don't exist. Okay, so a number, if it's not rational, it can't be a number, right? So the only true numbers are the rational numbers. But I'm not going to spend any more time on this. If you search for a comment here on this page, I have to end very soon. Philosopher. Here you go. There's one comment. So this guy says on a basic level he dislikes infinity. Of course, it's a garbage concept. And I never, by the way, use, if I've said infinitely many, there's no such thing. What I mean is that there are innumerably many such ordinates. Okay, so I'm running out of time, and I think I've covered as much as I can. 15 minutes is all I have. I'm John Gabriel. This is a new calculus channel. Till next time, goodbye.